Test, Test. Test, Test.
Also auf alle Fälle so laut sprechen, dass du dich selber hörst und denkst, oh, das ist zu laut. Das ist genau richtig. Okay? Dann sagt Bescheid.
Okay, so I am Sylvester. I'm going to talk about microcontroller-based chiptunes. I'm from Karlsküste, Kiel, which is a local chaos trap in Kiel. So, this is an example implementation of a hardware chiptune. It consists of a microcontroller. That's a Atmega 168 running at 8 megahertz. The digital to analog converter is actually a R2R resistor ladder. The only thing you have to do is connect 5 volt of DC power to it and connect it to your amplifier, and it just plays some chiptune, as I'm going to show you. Okay, so thank you. Thanks. So more things to say about this project. This project is actually based on Linus Eckerson's hardware chiptune project, which was pretty inspiring, and it was a real great experience to work with it. And I've just decided to compose this tune, which is actually inspired by a C64 game. Yeah, and what I'm gonna do is make an Arduino shield. So if you want to make chiptunes with your Arduino, you can get a Arduino shield for that. Okay, so this is my contact information in case you want to get in contact with me. If you get any questions, you can ask me after the talk. Okay. Thanks.
Okay. Next talk is Monsieur W. Oh, I'm sorry. Next talk is Monsieur W. And after that, I'm sorry, we hear about the web application fingerprinter. Are you ready? Are you okay, good.
Do you know these USB sticks that look cute and are really a little bit thicker than usual? They don't work when the USBs are next to each other. So, yeah, don't buy this.
Not mine. Yeah. Can anyone hear me? Can you hear me?
No.
No? Okay. Can you hear me? Okay.
As a general rule, if you think it's too loud, it's good.
Okay.
If you don't hear yourself, it's bad.
Okay.
So, yeah, take a minute. Got that? Schauen wir bitte in die. Okay? Gut. And tell us when to start. Okay?
Okay.
So ready if you are?
Yeah. Okay. I'm going to talk to you about a Linux distribution named Hackable 1. It's intended for the embedded platforms. It implements the GNOME mobile platform, that is GTK, gconf, dbus, evolution data server, and so on. We use Debian as a base. That means you can have any Debian package. They are built for a lot of architectures, like the ARML one. We are using mdebian as a toolchain for the cross compilation, which come with a handful set of a compiler, toolchains, and so on. Libraries compiled for the ARML. Okay. What is our goal? We want to set a Debian mobile distribution that is capable of running on a wide set of embedded phones, like the OpenMoko Freerunner. You may know it. We want also to port it on other devices in the near future. We use the GNOME software stack and guidelines to achieve that. That means we are following the GUI handlines, the HED handlines, and so on. So, like I said, we are using mdebian for the toolchain part. We also have wrote our own script for the packaging system and build system. The GUI part will be built up from the software stack that was made by OpenMoko and OpenHand. There's a very good set of libraries putting GTK, an evolution data server, and so on together. And for the phone stack part, we will use freesmartphone.org or FSO. For now, we are not using it, but our work in the next month will be to port the existing applications to FSO. FSO is an API for it's a middleware for device-related, for phone-related stuff and device like accelerometers, GPS, and so on. So next to the lightning talks, I will be running an Hackable 1 workshop to show how to make a package for Hackable 1. It's as easy as to make a Debian package, but I will show you how is our toolchain. You will be able to port your applications to Hackable 1 if they are not already packaged in Debian stable. And come and ask me if you have any question. So the contact is at the website is track.hackable1.org. You can send me a mail, or you can also subscribe to the mailing list. The mailing list addresses are on the website. And yeah, if you are GNOME, Debian, and OpenMoko